Today we'll solve two problems that is on two hinged parabolic arcs. You know already that is what is the analysis of two hinged parabolic arcs. This is the equation of parabola y is equal to 4hx L minus L x by L square, and this is the horizontal thrust. Using this formula, you can find out the horizontal thrust. Already we have discussed this is in last class, and you can find out what is the horizontal thrust. And today we'll find out the bending moment at a section and how to draw the bending moment diagram of the two hinged parabolic arcs. Let us take one question. Question 1. This is a two hinged parabolic arch of span 30 meter and rise 6 meter, carries 2 point loads, each 60 kilonewton, acting at 7.5 meter and 15 meter from the left end respectively. The moment of inertia varies at the secant of slope. Determine the horizontal thrust and maximum positive and negative moment in the arch rib. So this is your parabolic arch, and the span of the arch is given 30 meter and rise is given 6 meter. Carries 2 point loads, each 60 kilonewton, acting at 7.5 meter and 15 meter from the left end respectively. So this is your right hand and this is left hand. So from the left hand, at the distance 7.5 meter, there you are having one concentrated load 60 kilonewton. Again at 15 meter, having another load 60 kilonewton. Determine the horizontal thrust. You have to find out what is the horizontal thrust. You have to find out what is the horizontal thrust and maximum positive and negative moment in the rib arch. And you have to find out where you will get the maximum positive moment and where you will get the maximum negative bending moment. That you have to find out. First you have to find out what is the horizontal thrust due to this load and what is the horizontal thrust due to this load. There is a two concentrated load at a distance 7.5 meter and 15 meter from the support or left support. You have to find out what is the horizontal thrust due to this one, 60 kilonewton, and what is the horizontal thrust due to this. And the total horizontal thrust is the H. So here, horizontal thrust due to 60 kilonewton at 7.5 meter from A, that you can denote by H1. Then horizontal thrust due to load 60 kilonewton at 15 meter from A is equal to H2. The total horizontal thrust at the support is equal to H is equal to H1 plus H2. But you know already in last class we have solved one question when there you are having one concentrated load at a distance A from the support A or left end. What is the horizontal thrust already we have derived. This is your H1 is equal to 5 by 8 W by HLQ A into L minus A into L square plus LA minus A square. This is the formula when you are having the concentrated load at a distance A from the left support. So using this formula, you can find out what is the horizontal thrust. So here you consider this as a one concentrated load at a distance A from the support A, and this also you have to consider as a concentrated load at a distance A from the support A. So for this load, you have to take A is equal to 7.5 meter. And for this load, you have to take A is equal to 15 meter. Find out what is the horizontal thrust due to this one and due to this one. So due to this load, the horizontal thrust you take H1, and due to this one, the horizontal thrust you take H2. So H1 is equal to 5 by 8 W by HLQ A L minus A L square plus L minus square. So W is equal to 60 kilonewton. H is given 6 meter. H, the height of the rise is given 6 meter. Then L is given 30 meter, and A is you take in first case for first load you take the A is equal to 7.5 meter. 7.5 meter. So find out what is the horizontal thrust due to this load. Horizontal thrust is equal to 5 by 8, 60 by 6 into 30 cube, 7.5, 30 minus 7.5, 30 square plus 30 into 7.5 minus 7.5 square. Then H1 is equal to 41.748 kilonewton. Then find out what is the horizontal thrust due to this load. Find out what is the horizontal thrust due to this load, H2. So H2, so in this case, you have to take the A is equal to 15 meter. When you are considering this load, and due to this, when you find out the horizontal thrust H2, so A is equal to 15 meter and L is equal to 30 meter. So here you put this value 5 by 8 and W 60 and H is your 6 and L is your 30 and A is your 15. Then L 30 minus 15, L 30 square, L 30 into this is your 15. H2 is your equal to 58.549 kilonewton. So this is your horizontal thrust due to this load, and H2 is your due to this load. Then find out what is the total horizontal thrust. H is equal to H1 plus H2, 41.748 plus 58.549. The total is equal to 100.342 kilonewton. Then the next thing you have to do, you got here horizontal thrust. Then find out what is the maximum positive and negative moment in the arch. You can find out the bending moment. You can plot the bending moment diagram. First you have to find out the beam moment. Then you have to find out that due to horizontal thrust, what is the moment. Beam moment diagram is only due to the vertical load. Minus, this is the moment due to the horizontal thrust. This is the moment. HY diagram means this is the moment due to the horizontal thrust. So the total bending moment diagram is equal to beam moment diagram minus HY diagram. So maximum positive moment occurs under any one of the concentrated load points. So you know that is here there is you are having one load and here there is you are having one load. So the maximum positive moment you will get under this concentrated two load. Any one of these two concentrated load. Either you will get the maximum positive moment here or here also. You will get the maximum positive moment. Maximum positive moment occurs under any one of the concentrated load points. So what you have to do first? First you have to find out the reaction. Here you see the vertical reaction at VA and vertical reaction at B is equal to VB. This is VA and VB, and there is you are having two concentrated load. So you have to find out what is the vertical reaction A and B. So you know that is how to find out. So by taking moment about one point, then you can find out the vertical reaction of another point. So taking moment about B. So taking moment about B. So here you have to take the moment. Taking moment about B. So how many vertical forces here? VA into 30. So this is your clockwise rotate, and due to this load, this is anti-clockwise, and due to this load, the moment is your anti-clockwise from this point. Around this point, due to this load, this is anti-clockwise. This is also anti-clockwise. So 60 into this distance is 15 meter plus 60 into this distance is 22.5 meter. VA into 30 is equal to 60 into 15 plus 60 into 22.5. 22.5. So this is you can find out VA is equal to 75 kilonewton. Then you find out what is the vertical reaction at B. So you know summation of the vertical force is equal to 0. You know summation of vertical force is equal to 0. So already you got here VA 75 kilonewton, and this is your 60 minus 75. So this is your 45 kilonewton. So here the vertical reaction at B is your 45 kilonewton, and vertical reaction at A is your equal to 75 kilonewton. You know how to find out the Y distance. This is here you want to find out Y. This is this vertical distance. You have to know what is the horizontal distance. You have to know the X. Then you can find out Y. What is the equation? You know the parabolic equation to find out the Y distance. So what is the parabolic equation? So Y is your equal to 4hx L minus x by L square. This is your parabolic equation. So using this equation, you can find out the vertical ordinate of any one point. And you should know the horizontal distance, X. You should know X, then you can find out Y. So here we'll find out what is the distance, Y. At this loading position, so you don't know what is the Y distance, you don't, but you know X 7.5 meter. So you have to find out Y, this Y. What is the vertical distance? You have to find out at the first loading position. At the first loading position, 60 kilonewton. So you have to find out what is the vertical distance y or vertical ordinate y using the parabolic equation. 4 into 6, height of the parabola is your 6, and x is your equal to 7.5, L is your 30, and x is your minus 7.5 divided by 30 square. So this is your equal to 4.5 kilonewton meter. So you got here the y distance at the first loading position is your 4.5 kilonewton meter. Then you find out what is the bending moment at a distance. Here you find out what is the bending moment, and here you find out what is the bending moment. Bending moment at a distance 7.5 meter from the support A. Find out what is the bending moment. Then find out the bending moment at a distance 15 meter here from the support A. So first you find out what is the bending moment here. So for this, so what you have to do? So the bending moment here is equal to the beam moment diagram minus HY diagram. You have to take the beam moment, what is the vertical load here, that due to that load you have to find out what is the bending moment here, and HY means due to horizontal thrust, what is the bending moment here, that you have to find out. So bending moment at a distance 7.5 meter from A is equal to M 7.5 is equal to beam moment minus HY, beam moment minus HY. So M 7.5 is equal to M at a distance 7.5 meter from the support A. Bending moment at a distance 7.5 meter from the support A is equal to 75 into 7.5. This is the beam moment. Then due to the horizontal thrust, what is the moment here? H into Y, horizontal thrust into the perpendicular distance. So H into Y. So Y already you got, that is your 4.5 meter. So what is the beam moment? Beam moment is your 75 into 7.5, and due to horizontal thrust, what is the moment? H into this one, 4.5 meter. This is 75 into 7.5 minus, this is the horizontal thrust. Already you got horizontal thrust. Horizontal thrust you got 100.342 kilonewton. So 100.342 into the perpendicular distance is your 4.5 meter. Already you got here. This is not kilonewton meter. So this is your meter. This is your meter. This is your distance. This is your meter. So here you got horizontal thrust, and this is the y ordinate. So this is your beam moment, and this is your HY moment. Due to this horizontal thrust, this moment, and due to the vertical force, this is the moment. So this is your called the beam moment, and this is your horizontal thrust moment. So the M 7.5 is equal to 562.5 minus 451.539. So this is equal to 110.961 kilonewton meter. So at a distance 7.5 meter. So here you got beam moment, this one. This is the horizontal thrust moment, and this is the net moment, net positive moment. You are equal to this one. Then you find out at the crown. This is the crown. Find out what is the bending moment at the crown. That is at a distance 15 meter from the support A. So here also you have to find out the beam moment, the bending moment at a distance 15 meter from A is equal to beam moment minus HY. So here first you take the beam moment. So how many forces here? This side vertical force. So this is one reaction, vertical reaction at A, and this is downward force you are present 60 kilonewton. Two vertical force. One is your upward force, and another force is your downward force. So you take the moment, the beam moment, you take the moment of these two force. So here the beam moment, that is your VA into 15. The horizontal distance is 15. This is your clockwise, and due to this one anti-clockwise, minus 60 into the perpendicular distance. Minus 60 into this perpendicular distance. Perpendicular distance is how much? 7.5 meter, because totally you are 15. So if this is your 7.5, then this portion is your 7.5. So what is the beam moment here? So beam moment is equal to VA into 15 minus 60 into 7.5. V is your 75 into 15 minus 60 into 7.5. So this is the B moment. Then you find out what is the moment due to the horizontal thrust. So due to this horizontal thrust, what is the moment here? So you know this is horizontal thrust and the perpendicular distance between them. This is the horizontal thrust. So what is the moment from this point? So h into perpendicular distance between them. So this perpendicular distance is equal to 6 meter. H into 6. So this is the moment due to the horizontal thrust. Horizontal thrust, you know, that is 100.342 into 6. Then, so this portion is equal to 675. This is the B moment, and due to horizontal thrust, the moment is 602.052. So this total positive moment is equal to 72.948 kilonewton meter. So where you got the maximum positive moment? At a distance 7.5 meter from the support A, you got the maximum positive moment. This is the maximum positive moment. But at the crown, the positive moment is less, but you got the maximum positive moment at a distance 7.5 meter from the support A. Then you have to find out the maximum negative moment. So the maximum negative moment occur in the right portion. Here you see the maximum negative moment is occur in the right portion. Just to draw the bending moment diagram here. This moment diagram is due to the B moment. This is the B moment diagram. 562.5. This is the B moment, the total ordinate, and this is the ordinate of the HY due to the horizontal thrust, 451.539. So this is your 562.5, and this point is your 451.539. This is your 451.539. This point is your 451.539, and this is 562.5. So the maximum positive moment is equal to 110.961. This curve, this is due to the horizontal thrust, and this is due to the B moment diagram. So here this is the ordinate of the B moment, and this is the ordinate of the thrust, horizontal thrust, and the difference is the maximum positive moment here, 110. Similarly, at the crown, this is due to the B moment, and here this is due to the horizontal thrust. Here the B moment is 675 at that distance 675, and the horizontal thrust moment is 602.052. This one is 602.052. The difference is equal to the positive moment, 72.948 kilonewton meter. So here you see, so this is the B moment diagram when we join this one, and this is the horizontal thrust. So this portion, in right portion, will get the negative bending moment. So because in right portion, horizontal thrust moment is greater than B moment, so you will get the negative bending moment in the right portion of the 2-hinge arch. Because here you see in left side, so the B moment is greater than the horizontal thrust moment. That's why, so here you got the, this side you got the positive moment, and here this is the moment is maximum. And but this side, when we will join this one, and when we will draw this one, horizontal thrust bending moment diagram is above than the B moment diagram. So you will get the negative bending moment this side, where you will get the maximum negative bending moment. You don't know, but you have to find out that position where you will get the maximum negative bending moment. So this position you have to find out. At a distance x, this is the distance x from the support B. Take one section, and at that section you find out what is the bending moment. Find out mx. Mx is equal to 45x minus this is the B moment, and this is the horizontal thrust moment. Vp is your 45. Vp into x, this is the B moment, and due to the horizontal thrust hy, so you know h is equal to 100.342, and y is the distance. Y the distance at a distance x, y is the distance y. So this is the bending moment at a distance x from the support B. And you know y is equal to 4hx L minus x by L square. So here x is your unknown. You have to find out x. So mx is equal to 45x minus 100.342 y. So this y value you put here, 100.342 into 4, h is your 6, 4h x, l is your 30 minus x divided by 30 square, l square, 30 square. Then after multiplication of this x, so this becomes 30x and this becomes minus x square. 30x minus x square divided by 30 into 30. Then after simplification, this equation 45x minus 2.676 into 30x minus x square. After simplifying everything, calculating this is the value into this square. Where you get the maximum negative bending moment, you don't know. So what you have to do, you take the differentiation of this moment with respect to dx is equal to 0. You have to equate with 0. And at that position, you will get the maximum negative bending moment. Here you got the equation, mx is equal to this one. So take dmx, the differentiation of mx with respect to dx is equal to 0. dmx by dx is equal to 0. Then after taking the differentiation of this equation with respect to x, so you will get this is the expression. Then after simplifying this expression, you will get x is equal to 6.59 meter. So here you will get the maximum negative bending moment. At this position, at a distance 6.5 meter from the support B, you will get the maximum negative bending moment. You don't know, so where you will get that maximum negative moment? So let us take one section here at a distance x from the support B. So from this support, you take one section. You take one section here and find out what is the bending moment at that section. Then you put this value, x is equal to 6.559, and you will get maximum negative bending moment. So maximum negative bending moment is equal to 45 into 6.59 minus 2.676 into 6.59, then 30 minus 6.59. So this is the maximum negative moment. So m6.59 from B is equal to minus 116.28 kilonewton meter. At a distance 6.5 meter from B, you will get the maximum negative bending moment, minus 116.28. This is the B moment diagram. So this is your positive. Due to horizontal thrust, the bending moment is your negative. The value is lesser than this one. So negative is your more. So here you got minus 116.28 kilonewton meter. This is the bending moment diagram due to the horizontal thrust, and this is the B moment diagram. This is due to the vertical force. This is your final bending moment diagram. Now you are clear. So how to find out thrust and bending moment, the positive and negative, and how to plot the bending moment diagram. So another question here. A 2-hinged parabolic arch of span L. This is your span L, and rise H carries uniformly distributed load W per meter run. Carries uniformly UDL, uniformly distributed load UDL W per unit length for the whole span. Throughout the span, there is having the uniform distributed load W per unit length. Assuming I is equal to I0 sec theta. Moment of inertia. This is your I0 sec theta. You have to find out what is the horizontal thrust developed due to this uniformly distributed load. Then you know, just have to find out the vertical direction at A and B. And this is the UDL is your present throughout the span. So what is the vertical direction at A and B? So total load is your W into L. This is W per unit length. And what is the total load you are acting? W into the length of the arch. What is the vertical direction at A? Half of this load, WL by 2. And what is the vertical direction at B? Half of this load, WL by 2. Because this is your symmetrical arch and the symmetrical loading. So the half of the load will share by reaction at A, and another half is your reaction at B. So VA is equal to VB is equal to WL by 2. Then B moment at point PXY. What is the B moment at point PXY? At this point, what is the B moment? So B moment, that you know that you have to find out only due to the vertical force. What is the vertical force? You are here, vertical direction, and if you want to find out here, means you have to consider also this portion UDL. So this is also vertical force. This portion UDL also you have to consider when you will find out the B moment at the position P. B moment at point P xy is equal to mx dash. B moment is equal to WL by 2 into x. You know, this is a reaction WL by 2 into the perpendicular distance with x. WL by 2 into x. So this is, and due to this UDL, what is the load? W into for this portion x. So total load is Wx. And what is the centroidal distance? What is the moment? Into x by 2. Here this is your clockwise, this moment, and this moment is your anti-clockwise. So here WL by 2 into x minus Wx into x by 2. So Wx square by 2. So this is the B moment. So here you take Wx by 2 common, Wx by 2. So L minus x, Wx by 2 into L minus x. Then you know what is the parabola equation? Parabola equation is equal to 4hx into L minus x divided by L square. This is the parabolic equation. What is the horizontal thrust? You know horizontal thrust. Horizontal thrust is equal to integration of m dash y dx divided by integration of y square into dx. This is the formula for horizontal thrust, and here this is the y ordinate. You can find out from this parabolic equation. The horizontal thrust is equal to m dash. This is your wx by 2 into L minus x into what is the y ordinate? Y is equal to 4hx into L minus x by L square. This y. Here you put m dash because here you got m dash. So put here m dash, and the y, you know that parabolic equation. Put y into dx divided by integration of y square into dx. Y, again you take the square of this one, 16 h square x square into L minus x whole square divided by L fourth into dx. This is the horizontal thrust. Then after simplification, this h is equal to 2 wh by L square integration x square L minus x whole square into dx. And this is 16 h square by L4 integration of x square L minus x whole square into dx. Horizontal thrust is equal to WL square by 8h. Note, if only half the span is loaded, here the full span is loaded. The UDL is loaded full span. So here you got this is the WL square by 8h, the horizontal thrust. If only half the span is loaded, it can be proved that it is half the horizontal thrust developed when both halves are loaded with the uniformly distributed load. And in such cases, so h is equal to half into WL square by 8h is equal to WL square by 16h. When one half portion of the 2-inch arch is loaded by UDL, then that case you have to remember this one. So h is equal to half into WL square by 8h. So this is equal to WL square by 16h. One half is loaded means the horizontal thrust is equal to WL square by 16h. And when full length of the 2-inch arch if loaded, then that case the horizontal thrust is equal to WL square by 8h. Now you are clear that how to find out this one when they are having the UDL throughout the span, or if a half portion, then this is the formula. You have to remember WL square by 8h, and for a half portion WL square by 16h.